All right. So 2.6, proving statements about angles. Properties of angle congruence. So we were looking, the last chapter, we dealt with properties of segment congruence, right? And so you're going to find this with a lot of these properties as we're looking at them, that there will be, you may look at it for a segment, and then there'll be corresponding information about angles. And so these terms, reflexive, symmetric, and transitive, they're not necessarily going to go away right away. They're going to keep popping up. So theorem 2.2 has some properties of angle congruency, right? So theorem 2.2, I'm going to put that to the side over here actually, so we can refer back to it. Theorem 2.2, properties of angle congruency. And we have the reflexive property. Like I said, if you remember these terms when we've used them for line segments or the measurements of angles and segments, they're going to be very similar. So for any angle A, we can say that angle A is congruent to angle A. Symmetric property is that if angle A is congruent to angle B, then we can say that we can flip that around and angle B is congruent to angle A. And then finally, again, none of these should be shocking to you because they're similar to what we've already looked at with line segments. If angle A is congruent to angle B and angle B is congruent to angle C, then we can say that angle A is also congruent to angle C. So, again, these are things that you're going to want to put on your index card, right, for the Chapter 2 test. And make sure you know these properties and hold on to your index cards. You do not have to turn your index cards into me. Some of you did last time, which was fine, but I just... they tend to fall out when you're grading the test, and then I forget whose index card I'm looking at. So if you want to stick it in there and you just want me to review it or whatever, that's fine. Just put your name on the back so I can keep up with that. I don't want you to lose your index card. But these are all important things that you need to stick on your index card so that you will remember what these property names are. And so if you're doing a proof, you'll write down the correct name, right? So the first example they have in the book is they're wanting us to prove the transitive property of congruence for angles. So how can we prove that? So they draw some angles out here, and we're trying to prove that these angles are, we're going to label them A, B, and C. And so the given part is the stuff we're proving this one here, right? So the given part is that we know angle A, angle A is congruent with angle B, and then we also know that angle B is congruent with angle C. And so we're going to prove the transitive property, which means we're going to prove that angle A is therefore congruent with angle C. And so it should be sort of obvious to us, but by going through these steps and proving this, it's going to give us some practice on doing these proofs, right? And so we're going to do a 2-column proof here, and we're going to put our statements over here, and our reasons over here. And so typically, you start off with your givens, right? So we know angle A is congruent with angle B, and angle B is congruent with angle C. Those are both our givens. We can number those so we can keep them straight. 1 is given, 2 is given. And so as will often be the case, you'll kind of start with something like this, and then you'll sort of deconstruct it, and then put it together in another order to sort of to come up with your final answer. So a lot of times the proofs will work like that. And so as we sort of deconstruct these guys, by the definition of congruent angles, we can say if angle A is congruent to angle B, then that means that the measure of angle A is equal to the measure of angle B, right? That's what the definition of congruency says. The definition of, specifically in this case, congruent angles. If you just wrote down the definition of congruency there, I would give you credit for that, right? Because you're recognizing the fact congruency just means that whenever I'm talking about an angle or a line segment, if they're congruent, it means their measurements are equal to one another, right? So any questions about this statement? Or any questions about overall how I've set it up to start with? Is that making sense to everybody? I just drew the picture to help us, mainly because they did it in the book. But I understand why they did it, but the picture's not necessary, right? If you can map all this out in your head and you don't need the picture, that's fine. But a lot of times pictures will kind of help you visualize it, make sure you're going down the correct path. So if you're not looking at the book, what do you think would be our next thing that we're going to put?
The measure of angle B is equal to the measure of angle C by the
Yeah.
definition of congruent angles.
So basically the same thing we did for the previous angle A and B, we're going to do that for angle B and C, right? Also by the definition of congruent angles, right? So now because of that, we can say, because of what we previously learned, we can say that the measure of angle A is equal to the measure of angle C. If measure of A is equal to the measure of B, and the measure of angle B is equal to the measure of angle C, then we can say the measure of A is equal to the measure of angle C. And we learned that a few chapters back. We were given a property for that. And that is on page 98. It's the transitive property of equality. And it's that the transitive property, the way it always works, right? If A equals B and B equals C, then we can say A equals C, right? So we would write down for this, we can make that connection because of the transitive property of equality. And then finally, we're going to use the definition of congruent angles again, because if we've got the measurement of two angles that are equal to one another, then we can say that those angles are therefore congruent to one another. So the definition of congruent angles. So we're just proving the theorem that I just gave you, right? We're proving this, but we were using that proof as an example so that you could have another opportunity to practice creating these proofs here. And it's interesting, right? For half of our reasons, we're using the same property. We're using this, it's not a property, it's a definition. We're using the definition of congruent angles. We use that 3 times to make our proof. So you may use the same property or theorem or definition multiple times as you're building your proof. But like I said here, we sort of deconstructed it, right? We knew these angles were congruent, and so then we could deconstruct that and say that meant that the measurements of those angles were congruent. And then by the transitive property of equality, we're able to make this statement here where we set the measurements equal to one another, and we use the definition of congruent angles again to make our final proof. Anybody have any questions about these steps here. And do you think you could do that on your own? Do you think it's starting to click well enough yet that you're ready to do something like that on your own? Think so?
Yes,
Yeah.
sir.
Well, I'm going to go and give you guys chapter 2 test now. So let's get it out of the way.
Perfect. I already have an index card.
Oh boy. No, seriously. Any questions about that? Did I lose anybody anywhere? What I don't want you to get caught up in at this point is like, why are we doing this? Because this is not typically one we would prove, but because now that I've given you this, you can use this theorem as your proof going forward, right? You can use this in future proofs, but we were just proving it here so that you'd have an opportunity to practice doing proofs. All right, let's try another one. And this one says, again, I tell you what, try not to look at the book as I'm doing these so that you guys will, that it'll be better for you learning how to do it if you're connecting the dots. Wait a minute, somebody, you said it, right? Okay. Sorry about that. I'm feeling really bad because I think I forgot to write somebody down in the pre-calc class. They're probably crying, some are crying right now. Measurement of angle 3 equals 40 degrees. Let's see. Angle 1 equals, no, it's congruent to angle 2. And angle 2 is congruent to angle 3. So that's what's given. And they said prove that the measure of angle 1 equals 40 degrees. And they give us this helpful diagram here where we've got something that looks like this, and then something that looks like this.
Jeez.
And 1, 2, 4, 3. All right, so
Interesting.
statements, reasons, measure of angle 3 equals 40. So I'm just going to put a 40 right here, 40 degrees, just so we'll have that. And angle 1 is congruent with angle 2, so these two are, and angle 2 is congruent with angle 3. And they want us to prove that that means that angle 1 has to be equal to, the measurement of that has to be equal to 40 degrees. So we could do this, right? This actually is very similar to what we've already done. For this particular one here, they just listed all of the stuff in step 1. That's fine. Those are all given. Instead of separating those out, they just went ahead and put it all in a given there. Occasionally, I think we saw a problem last week where it's helpful to list like a couple of the, I think we listed like one given or two givens, and then we made a statement that connected that, and then we listed another given. Occasionally you may list one of your givens separately and a little further down the road as you're building your case. But this will be fine for this. And so what we don't have to do this time is the step that we did last time where we proved the transitive property theorem. The transitive property of congruence, which is part of theorem 2.2. We can just immediately use that property now. And so because of that, we can say something about angle 1 and angle 3. What can we say?
Angle 1 is equal to angle 3.
You're close. You almost, it's congruent, right? You have to say it the right way because we're talking about the angles, not the measurements of those angles, right? So angle 1 is congruent to angle 3, and we know that because of the transitive property of angle congruency. Or or just transitive property of congruence is what they wrote down there. All right, now we're trying to prove that measure of angle 1 is 40 degrees. And so here we've proven that angle 1 is congruent to angle 3. So we're actually almost there, right? If we know that that's the case, then we can also say that the measurement of angle 1 is equal to the measurement of angle 3. So that's why I had Cameron restate what she said, right? Because she sort of did a mixture of these two statements. And I'm going to keep going back to that to make sure we remember. We can't directly say, we don't say these are equal to one another. We say the angles are congruent to one another, just like we say the line segments are congruent to one another. But then when we talk about their measurements, we can say that they're equal to one another, right? So because of this being true, then we can say this is true. And what tells us that that's so?
The definition of angle congruency.
Yeah. So again, you've got, this time I'm just going to write it this way. Definition of congruency, right? I'm okay with you putting that down. I know what you mean by that. But you could write congruent angles, that's fine as well. So again, we're nearly there. We can actually, at this point, then make our final statement, which is the measure of angle 1 then has to be equal to 40 degrees. Who can tell me why we can say that based on the last statement?
Well,
What
because
previous property or something? Cal's got his hand raised, so I'm going to give you a second to try to work it out. She went ahead, Cal. Let's see if she crashes and burns. Is that how I would say that? If you crash and burn.
so a property.
A property, yes.
Um,
That's a good start. That's a pretty good guess.
no, I was asking if you wanted a property.
Yeah, that's what I'm looking for. Yep.
Okay. Would that be the transitive property, or no?
You're in flames.
I thought you were asking for something else, so that's why I said it.
No. So I see what you're thinking there, and you're doing this in your head, right? You're saying, well, if angle, do you guys see how she's connecting those dots and she's thinking that it would be transitive property? We'll let Cal get it, okay? But she's putting that together because she's going in her mind. She's like, well, I know that the measure of angle 1 equals the measure of angle 3, and I know that the measure of angle 3 equals 40 degrees, so couldn't I kind of do the transitive property thing? If this equals this, and this equals this, then I could say the measure of angle 1 equals measure of 3. Actually, let me say this. I wouldn't count that wrong. Because I could totally see where you would put that together, right? That you could say by the transitive property of equality that if this equals this and this equals this, then I have to say that that equals that. So yes, I'll agree with that. You didn't crash and burn. I'm the one that crashed and burned, right? Because I said no. And now I feel really bad about that. So I'm going to give you $5, okay? No, I'm kidding. I don't really have $5. But, so Cal, what were you going to say?
The substitution property.
The substitution property is another way that we could do that. Do you see that? Mm-hmm. So the substitution property says that since I know that the measure of angle 3 is equal to 40, which I stated right here in my given, I can then substitute 40 for the measure of angle 3 in this equation right here, right? And just directly take it and say that. So I'm glad that you said it that way, Camille, because that makes an important point. There's not necessarily one way to get to prove these things, right? There are multiple options. And so sometimes I'll say this. If I count something wrong and you're like, no, that totally makes sense in my, if you can come and defend that to me, right, then I may still give you credit for it. All right? Because I just may not have connected the dots that you connected in your mind. And when you explain it to me with the way you're thinking, I'm like, oh, okay, yeah, I can see how you can do that. And so, I mean, that happened whenever you first said that. It wasn't until I wrote this out that I'm like, yeah, that totally looks like the transitive property. So I would have counted that as well. Okay? Mm-hmm. All right. Any questions about this? And the fact that there are multiple answers sometimes? And it would have been, which transitive property would it have been? Which one did you say it was?
Of equality?
It would have been the transitive property of equality, right? It would have been the one on, like the one on page 98, where you have the measure of one angle is equal to the measure of the other angle, then, or the transitive property of equality, kind of the idea on page 96 as well. Both of those would be where you would, where you would get the transitive property would apply there. It's the transitive property of equality. All right, let's move on to another example. I'm kind of taking my time on these because these are sort of, these are tough to get your mind around. But we do have another angle, another theorem to introduce to you, which is theorem 2.3. And so let me just say, anytime you see something boxed off in the book, that's a good indication that there's probably something in there that you need to write down on your card, right? That you need to, I would simplify it and write it in your own terms, right? So that you'll understand it, but put something in there so that you know about that particular theorem or property. So this is the right angle congruence theorem. And it just simply says all right angles are congruent.
Wow.
Exactly, right? I mean, I'm going to have to send you guys home so you can ponder that the rest of the day, right? Just to make sense of it. All right angles are congruent. And so they actually ask us in the next example there to prove that. And it's a good example to look at because you can see that there's just some things that you have to know, like what would you write down? Let me just write down the steps so I can point to those. So if we proved that, we had angle 1 given, angle 1 and angle 2 are right angles. And then prove then that angle 1 has to be congruent to angle 2. We would have, I'm not going to write down statements and reasons just for time's sake. Angle 1 and angle 2 are right angles. That's our given. And then for number 2, that means the measure of angle 1 equals 90 degrees, and the measure of angle 2 equals 90 degrees. I just want to point out with this step here, sometimes there may not be something that we specifically covered in this chapter that would let you write down this statement. But you're supposed to just know what would be correct there. What would it be, Aiden?
Would it be not the property, but the definition?
Yeah, it would just be, that's what the definition of right angle means, right? By definition of right angles. So by definition, we know that right angles, that means it's 90 degrees. And so that's how we make that shift. So sometimes you may be going back to something in a former math career, right? Your former math experience was things that we've just accepted as being true because we've learned it so long ago, but it's just a definition in our mind. So that's how we define right angles. I can't remember if they've actually said that in this book up to this point or not, but we just knew that coming into this course, right? That if I tell you it's a right angle, you know it's 90 degrees. All right, so if we know that, then we can also say that the measurement of angle 1 is equal to measure of angle 2. And again, we could use they use the transitive property, which is the one that you picked last time, right? Mm-hmm. Transitive property of equality. Again, if you wrote down the substitution property, and I counted it wrong and you came and made an argument for that, I would give you credit for that, right? Because I could see where you could also use substitution for that as well. And then finally, by the definition of congruency, then we can say that that angle 1 is congruent with angle 2. All right, so we're just getting a lot of practice on proofs today, right? Because they're going to stick around a while. They're going to keep popping their ugly heads up throughout the course, right? So it's good to start off small here and kind of thinking through it, because we're going to need to know this well down the road. It's going to show up. When we're doing things like proving triangles are similar, or proving that triangles are congruent, we're going to have to know this stuff. All right, let me introduce a couple other theorems. Theorem 2.4. Theorem 2.4 is the congruent supplements theorem. When you hear supplement, you should think what?
The supplementary.
Supplementary equals how much?
180.
180 degrees. So you're combining angles together, and they're going to be equal to 180 degrees. The next theorem is going to be called congruent complements theory, and that should make you think, you add them together and you get what?
90.
90 degrees, right? So the congruent supplements theorem says two angles are supplementary to the same angle. Or two congruent angles then they are congruent. And so to write that out here, where do I want to do my little, I don't want to do my drawing. I'm gonna, I guess to leave room on the board, I'm gonna do my drawing like this. So 1, 2, 3. And so what my problem actually says is if the measure of angle 1 plus the measure of angle 2 equals 180, and the measure of angle 2 plus the measure of angle 3 equals 180, then angle 1's got to be congruent to angle 3. And that should make sense to us, right? If angle 1 and angle 3 right here are both separately being added to the same angle for a total of 180 degrees, so angle 2 doesn't change, then angle 1 and angle 3 have got to be equal to one another, right? You put in your mind, you can put actual numbers in there. If angle 2, for example, is 100 degrees, and I know that the measure of angle 1 plus 100 degrees is 180, and I know that that 100 plus the measure of angle 3 is 180, then angle 1 and angle 2 both have to be 80 degrees, right? So what are you going to write on your index card? These get kind of long if you write all of that down, right? So I would just kind of write this portion down here and then draw a picture if it's necessary for you to understand what that means, right? I would kind of stay away from the long wordy ones and focus on the kind of symbol ones that are quick and easy for you to process while you're doing a quiz or a test. But like I said, some of these, when you write these down, they may not make as much sense if you don't do a little drawing out next to them. So you may need to do the drawing as well. And then I'm not going to write it down for time's sake, but theorem 2.5, which is the congruent complements theorem. It's the same exact thing, but it's got a 180 in there. You've got 90 degrees in there, right? It's the same exact idea. You take one angle, add it to another, and you to a second angle, and you get 90 degrees. And then you take a third angle and add it to that second angle and get 90 degrees. Then the first and the third angles have got to be equal to one another, or congruent with one another. So, they want us to prove that. So again, in the interest of making sure you guys have as much practice as possible in doing these proofs, we'll work this one out. Angle 1 and angle 2 are supplements. Angle 3 and 4 are supplements. Angle 1 and angle 4 are congruent. So that's given, and you need to prove then. If we're proving this theorem here, what do you think it is that we're proving here? Somebody besides who's already on the board? Can you tell me that? What do you think we're going to try and prove then? Based on this theorem right here. Yeah, oh, I haven't put you on the board yet. You answered something, didn't you, Aiden?
I did.
Okay, I'm going to go and write you down. So someone besides Aiden. Don't be scared because the whole crash and burn thing is just a joke. All right? I knew Camille could take it. Anybody want to take a stab at it? What do you think we're proving if I'm trying to prove that theorem? Gabe?
Angle 2 is congruent with angle 3.
Angle 2 is congruent with angle 3. Exactly. Right? Because these two have to be equal to one another if these two are equal to one another. The measurement of those two are equal to one another. Because they're supplements. They both have to add up to 180 degrees. All right, so let's prove that. Statements, how about I just do S and R? We'll save time that way. How about that? So we have all the given stuff, and I'm not going to repeat that. Right, we've got this stuff here that's just given. At the top. So, number 2, how would I want to tackle this guy? How would I prove this? Let's see if we can do it. Again, try to do it without looking at the book. All right? I'm gonna take this journey with you guys. I'm gonna try to not look at the book as well. All right, see if we can figure it out. You're about to discover just how dumb your teacher really is. All right, so let's see if we can do it. This is where I get to edit the film later, right? So let's kind of break it down, right? We've got this that's given up top here, but we need to prove that this is so. So So we know that angle 1 and angle 2 are supplements, so that actually means that they're going to be equal to what?
180.
180, right? So we know by definition, that's one thing that we could include in there. Sometimes the order, I don't know what order they do it in the book, but sometimes the order can vary as well. So we know that the measure of angle 1 plus the measure of angle 2 is equal to 180, right? We can say that's the definition of what?
Supplementary angles.
Yep, supplementary angles. Who said that? Jackson. All right, I'm down the room here. Jackson. All right, and so we can also say the same thing about measure of angle 3 and measure of angle 4 by the same definition. Definition of supplementary angles. All right, so there's that piece. Anybody want to take a stab at the next one?
You could say measure of angle 1 plus measure of angle 2 equals measure angle 3 plus measure of angle 4.
Yep, I was thinking that. I like that. Hopefully we're not going to back ourselves into a corner, but I'm thinking that's a good idea. Right? So the measure of angle 1 plus the measure of angle 2 equals the measure of angle 3 plus the measure of angle 4. What would I use to prove that? Or reason?
Substitution.
Substitution, okay. So substitution, property. So good, we're making progress. Now what could we do? How about, maybe we should have done this before, but isn't it true that we could say that the measure of angle 1 is equal to the measure of angle 4? Right? How would we know that?
Just a given.
No, it's not.
That's the definition of congruent or not.
It's congruency, right? It lets us know that. So this was what was told us. Angle 1 is congruent with angle 4, and so the definition of congruent angles tells us that the measure of angle 1 is equal to the measure of angle 4.
Mm-hmm.
All right, now I like where this is headed. This is looking pretty good. So now we could actually rewrite this number 4 here, and say then we could plug in one of these for the other. Right? You guys agree with that?
Mm-hmm.
So I could say we'll leave measure of angle 1 in there. Measure of angle 1 plus the measure of angle 2 then has to equal the measure of angle 3 plus the measure of angle 1. Right? And how did I know that? Why do I keep doing that? 6, not 7. How do I know that? Why was I able to do that?
Substitution.
That's just substitution, right? Technically, what the substitution property of equality would be the full thing. All right, so we're getting pretty close. Now I can subtract the measure of angle 1 from both sides, right? And that leaves me with just the measure of angle 2 equals the measure of angle 3. And that's the subtraction property of equality, right? If I wrote it all out, be that there. We're almost there, guys. Number 8. So now we can say angle 2 is congruent with angle 3. And why can I say that?
Definition of
Because
congruency.
of the definition of
Definition of congruency. That's definition of congruent angles. All right. So looking at the book here, we did pretty good. Actually, we did great because I'm like, we have 8 steps and they have 7.
They
Wow.
mash,
They put these two
Oh,
together.
they
Yeah.
put 2 of them.
Yeah, they put those together. So yeah, you may not. Mileage may vary, right? You may not get exactly the same way, but as long as what you're writing here makes logical sense and you can prove that, right? And you get the correct answer at the end, you'll be good on the proofs. And like I said, just from a test perspective, most of the time, what I'm going to do is I'm going to give you some steps and I'll leave blanks like I did on the quiz, and you'll kind of fill in the appropriate blanks. All right?
Mm-hmm.
Okay, any questions about that? Did I lose anybody anywhere? I'm so glad I didn't turn out to be a dummy on film, right? All right, let's do another postulate, not a theorem this time, but we've got a postulate. I was wondering as I'm looking through my notes why only one chapter was covered last time, and now I get it. There's a lot of material to cover in this one. Postulate 12, which is the linear pair postulate. Now, if you're going to list this in a proof, I'm not looking for you to list postulate 12, right? I'm looking for you to list this name here, linear pair postulate. So if you're including that in a proof somewhere, give me the descriptive name so that I'm not, because I'm not, if you put down for number 4, it's postulate number 12, I'm not going to go back through the book and go, oh, what was that again? Now, I want to see this descriptive name here, okay? And so this says if two angles form a linear pair, then they are supplementary. What does supplementary mean?
180.
They added 180. Did you say that, Mary? Oh, you didn't. You were like chewing some gum or something while somebody was saying it. It was like, there's not, I don't know, 180. Who said that? Oh, you said it? You said it? Oh, Joshua said it. Okay, I thought I heard a voice further in the back. All right. He's a ventriloquist. All right, so let's draw a picture of that. So here's our, when we say a linear pair, what do we mean by that? We mean that we've got a line, right, and then we've got an array coming off of that line that forms two angles, right? So we've got angle 1 here and angle 2 here. And so what our postulate says is that the measure of angle 1 plus the measure of angle 2 has to equal 180 degrees, right? That makes sense, because we know that the measurement of this is 180, right? The measurement of the angle, that's what we call a straight angle, right? Angle made by a line. Questions about that postulate and what a linear pair is? Have we talked about a linear pair in here before? Is this the first time?
Yeah,
Talked about
right.
Okay, that was defined earlier. I couldn't remember. So then this should be old news, right? That should be pretty obvious to us. And so here's a problem that's not actually a proof. We're going to get a numeric answer. And so they give us this drawing here, and they give us something that looks like this, and they label the angles 5, 6, 7, 8. And they say that they tell us that the measure of angle 8 equals the measure of angle 5, and that the measure of angle 7, the measure of angle 5 is 125. And so, can we from that figure out what, they asked us to show it, but I just want to see if we can figure it out. What would the measure of angle 7 be equal to? Another little angle thing out there. All right. So what does measure of angle 7 have to be?
Equal to the measure of angle 6.
It is equal to the measure of angle 6, but what's the actual number? How do we figure that out?
You subtract 180, or you subtract 125 from 180.
From 180, right? So because if we think about it, if these two angles are equal to one another and both of these are 125 degrees, so I could write 125 degrees here and 125 degrees here. And so angles 7 and 8 form a linear pair, and so we know that the measure of angle 7 then plus the measure of angle 8 has to equal 180 degrees. So I could say the measure of angle 7 plus 125 degrees equals 180 degrees. The measure of angle 7 then has to equal 180 minus 125, which equals 55? 55 degrees, right? Yep. Everybody follow that logic? So we could have written a proof, right? I could have said, show me a proof for that. And we would have walked through the same steps that we just did in our head. We'd have spelled that out and explained why we could say that was the case. All right, our final theorem for today is the vertical angles theorem. Vertical angles theorem, and it says vertical angles are congruent. And so if I have a drawing like this, and I've got vertical angles formed by those two lines intersecting, then angle 1 is congruent with angle 3, and angle 2 is congruent with angle 4. So we'll do one final proof, and then we'll have a little bit of time just to review some chapter 2 questions that you may have. So we're given angle 5 and angle 6. Our linear pair, angle 6 and 7? Yes. 6 and angle 7 are linear pair. Draw a picture so we can visualize that. 5, 6, 7. And prove that angle 5 is congruent with angle 7. So we're proving the theorem that we just stated, right? Angle 5 and 7 are vertical angles. So based on what we already know, how can I prove that those angles are indeed congruent to one another like our vertical angles theorem said? So we have our given. It's a pretty simple proof, right? Our statements and our reasons, and we've got this first one, which is all the stuff that's given at the beginning. But given that, we can say that angle 5 and angle 6 are 180. I'm going to say supplementary. So that's actually what our, that doesn't look like supplementary, but it is. All right? So if I do like this right here and I say that's supplementary, that's what it is, okay? Sorry, I ran out of room there. I'll try to back up a little bit for my next one. Angle 6 and angle 7 are also supplementary. Oh, almost. Barely. Sort of.
You have to move the line.
I had to move the line. Yeah.
Mine was the same way.
Yeah, it wasn't? Okay. So, and the reason I can say it, the reason I said it this way, instead of saying that they are equal to one another, instead of saying that they were equal to 180 degrees, is because this is what the linear pair postulate says, right? So I can say that's true based on the linear pair postulate, right? And so then if that's the case, then based on this, over here, I can say that angle 5 is congruent with angle 7 because of the congruent supplements theorem. Right, because that theorem says if you've got two different angles, that when you add those two different angles to another angle and they're supplementary, then we know that those two angles have to be congruent with one another. Yes?
Will our test be this week or next?
I can't believe you're even asking me that question right now. I mean, this is, how could you not be wanting to talk about this? As exciting as that was, right? All right, let me finish this thought and then I'll answer that question, okay? This is what I want you to see with this. You could have completely deconstructed this and done the whole, which one of you, was it you, Cameron, that said that about 180 degrees? Mm-hmm. You could have gone that way, right, that route and torn it apart and said, well, this is supplementary, so that means they add up to 180 degrees, and then start talking about the definition of linear pairs and done all of that stuff, and it'd been much longer. And it would have been right in the end if you put all the puzzle pieces together and then took it apart, put it back together, then it got me the correct answer. But once you learn one of these theorems, right, these are all tools in your arsenal now. And you can use those to make it much quicker, right? So just be aware of that. There's different ways to do it, and you can take the long path sometimes when there's a much shorter path, right? And so don't forget the other theorems and how you might could use those other theorems in your proof. Any questions about this before I answer Cameron's question? Anything that we've covered today before I ask the bigger overall question about chapter 2? But first I'm going to answer your question. Nothing? You guys got all this? You had a bunch of theorems, right? A bunch of maybe not definitions, but that one theorem and that one postulate and a bunch of theorems today. So the question was about test 2. So this is what I'm thinking. I'm thinking we will take quiz, our quiz for this section next week, right? And what I think I want to do, because I think you guys can handle this, I think I want to hand out test 2 to you next week. Yes. To take it home. Mm-hmm. So that while this material is fresh on your mind, you go ahead and do chapter 2 before I'm giving you the chapter 3 assignment. Mm-hmm. Or getting far into chapter 3. Does that sound good?
Yes.
You like that idea better than how we did it last time?
Well, this is kind of like how we
Is it the same way? Did we do it the same way last time? I get you guys confused with pre-calc, because pre-calc's been a little different. But if I do that, it will mean I'm going to have to start lecturing on chapter 3 next week, right? But
yeah, that's how you did it last time.
We'll just be barely into it, right? And that way y'all can do that while it's fresh on your mind. And probably what I'll do, since you're going to be turning in, I may skip doing a quiz for the first part of chapter 3, just so that you guys can focus on getting ready for chapter 2. Okay? So to that point, I know you guys are like, yes, we're done, we're leaving. But before you put your stuff away, you have a rare 10-minute opportunity here, or maybe 5, 6, or 7 minutes if you've got a class right after this, to ask me questions about the chapter 2 material, right? Usually we're right up against the clock and we don't have time for this. So is there anything that you want to ask? Josh? What?
Would it be okay with you to use what
would I give you how many types of each problem? Is that what you're saying?
I think it means like study guide.
How many problems from each section? Yeah. I don't know the answer to that question right now. I mean, some like this section here, we've got a lot of theorems in it. So this one's probably going to have more problems than some of the other sections, just to kind of give you the opportunity to use multiple theorems there. But I will say your note cards are going to be key on this, right? Because we've got a lot of definitions, properties, theorems. Yes.
Or we can put anything we need to.
Anything you can fit on that 4x6 note card, you can put that on there. Okay? Yes.
You can still use the front, even though we have more information, like we're only allowed to use the front.
You're only allowed to use the front. Yes. Yeah. For now, right? But don't throw away your cards, because at some point I'm going to let you guys use like an entire page, or let you use front and back, and then you'll be able to take your previous ones, you know, like when you do a semester exam or something like that, and kind of combine those together. Okay? Does that make sense to everybody?
Yep.
All right. If you've got a question you want to ask me about separately from the class, I've got a few minutes, like 10 minutes before my next class starts, so I have time for that. All right? You guys have a good one.
You too.
Thank you.